Okay, welcome everybody to this evening's .NET Liverpool virtual meetup, where we have the co-author of open source software, Alexa.net. Welcome, Stephen.
Thanks very much.
As a thank you for joining the event this evening and being interactive, we've got some free JetBrains licenses to give away as well at the end of the presentation. So this would include software like Rider, which is an alternative to Visual Studio, ReSharper, which is a helpful extension. They've just released version 2020.3 with a pack full of features. So if you want to get involved and get one of these licenses for free, just put hashtag #ThankYouJetBrains in our chat, which is enabled on Zoom, and I will put your name into the random name selector. So my name is Joshua Duxbury. I work for a company called TLA, the lead agency, who are sponsoring this event. So thank you, TLA. Our community is dedicated to providing you with the best speakers, content, and learning resources around Microsoft technologies. So please subscribe to keep up to date with our channels. You can find all our channels located on www.netliverpool.org.uk for more information. So without any more ado, I'll hand you over to Stephen for this evening's presentation. Thanks, Stephen.
Thank you very much. See if I can share the right screen. Somebody tell me I can share my presentation.
Yes.
Can you see it?
Yes, I can see it, Stephen.
Yeah, cool. That's great. So yeah, thank you very much for having me. I'm Steve Pears, like I said, co-author of Alexa.net. I'll talk a little bit more about the repo in a minute. But yeah, just want to talk to you about what Alexa can do, and certainly at the moment, one of the things that people have noticed in this industry is that actually smart speakers and smart assistants have become more popular as lockdown and other measures have meant that we've needed other ways of communicating. And so it's been a really interesting time to kind of work with voice and start developing the kind of skills that we can do with Alexa. So a little bit about me. I work for Experian. So my day job is a solution architect in fintech. A lot of security, a lot of interesting challenges. I've been around long enough now that I don't say how long I've been a programmer, but it's that I've been responsible for. I'm really trying to get that number down, but yeah, last one happened 2 years ago now. And I'm a certified skill builder. So AWS certification has got a specialist certificate for Alexa skills. And I was lucky enough to be able to take part in the beta. So an official skill builder. All the information about Alexa is, one thing I did forget is I have an Alexa right in front of me, and she's now wondering what I'm about to say, so let me mute that. Otherwise, she'll be talking throughout the presentation. Yeah, so everything that I say is accurate as of now, but I am aware that right this minute, there is an Alexa hardware event happening. So if anything changes in the next hour, I apologize, but it was all accurate at kind of going to print. So these are some stats about the Alexa skills that are available. These are 2019, so these have increased quite a lot recently. But as you can see, thousands and thousands of skills. But the important thing is less the numbers and more the number of locales that are available now. So actually, Alexa is available in an awful lot of countries, and they're constantly increasing. But they're also increasing the number of languages that Alexa can be built for. So any individual skill that you build can respond to multiple languages, and the information is interpreted correctly. So this is the full list we have at the moment. The latest addition was Hindi India that was put in, but even creating English can be quite a time-consuming process because there are so many different versions. They have just created the ability to copy locales so that you can kind of base one on another and then make changes. But yeah, can be multiple locations, multiple languages, and multiple devices. So this is just a small selection of what's available. These are the ones you're probably more familiar with in the advertising. You've got everything from the small little Echo Dots to the Echo Shows at the back. That's an old one, actually. I need to update the image. And then you've got some like the device that you might not be familiar with on the far right, which is actually the deep lens camera. So it works with Amazon Alexa, as well as interpreting the image that it can see from the camera, and it lets you do some interesting work with skills and images at the same time. So with Alexa, there are thousands of devices that can work with Alexa, that have it built in, have it supported as something that can accept commands. There's about, this is going back to 2019, there's about 150 with Alexa built in. There are a lot of official SDKs, so Python, Node, Java are the primary three that you see in code examples. But certainly when I joined, there was no .NET SDK of any kind. And I was a little disheartened because I really wanted to see what I could do. And I came across a guy called Tim Hewer, who's a Microsoft developer advocate. And he'd created a .NET Core infrastructure for an Alexa skill. This was my first time in open source. I just wrote some tests to start with, literally just around the stuff that he'd done. He'd put an issue on the GitHub repo asking for help. And that was, what, probably over 2 years ago now. Now we have full support for every Alexa.NET API. It covers about 13 different NuGet packages, all based around Alexa.NET and all available from the primary repo. So this is the kind of the core functionality, and then you can download NuGet packages that have support for the other functionality that you require. And we'll go into some of that today. But essentially, what I'm going to show you is that although voice is what everyone knows it for, and that is still the primary when you certificate a skill, it must have full voice support. There's an awful lot more you can do than just have it speak words, and actually you can build some really rich experiences out of it. I'm going to use an example skill that I built called Rollcaster, and it's literally just I can roll dice. You ask it to roll 2 dice or 2 20-sided dice, and it will come back with the result. So it's a pretty straightforward skill. It's nothing fancy, but it's just to show that even a basic skill can have examples and richer experiences added to it when you start thinking about what's capable. So for anyone who's not developed a skill or not looked at Alexa yet, I'll go through kind of the basics of the flow. It's relatively similar to any other kind of API request you might have done. You have a user, the user says a phrase. The phrase has to start with what's called a wake word. So that is normally the word Alexa, which is why I've muted my device. But it can also be Echo, computer, Amazon. There are a selection of words you can have. And because of the security concerns, the way that the hardware is certified now is until the wake word is spoken, it doesn't start listening, doesn't start recording what you're saying to send it to anyone for analysis. So the wake word's important. You then say open and the name of the skill. So in my example, it would be open Rollcaster. When that phrase is spoken, that information is sent to the Alexa ecosystem, where it's translated for us into a request, and the request is a blob of JSON. That information is then sent to either to some kind of .NET code in our example. I tend to work with AWS. Alexa is a little bit more easier to be secured when it's AWS Lambda, but it can just be any public endpointed HTTPS connection. So if you have an existing API, existing functionality, and you want to kind of add Alexa on as an extra piece of functionality, then you can just create a new API endpoint for that inside your existing functionality. That's not a problem. You process the request information from the JSON, and then you return that as a JSON response. And what Alexa.NET does is essentially turn this request response into a fully formatted object model, strongly typed all the way through. It handles all the complexity in terms of translating types, and there is quite a lot of information available to you about the device and what's happening. The response itself then gets sent through the Alexa system, and they route that back down to the device that you need, and then that is translated back into speech. No matter what else we talk about, this is always the flow. There is voice, it's processed, you send a response. We'll talk about it later, but there are some instances where you can push information on demand, but even that has to have been based on an initial voice confirmation. One of the big rules about developing Alexa skills is it always has to be based on the user asking and confirming that you wanted to do something. And no matter how complicated or involved the skill or the functionality gets, it's still based on this request response idea. So there are two main sections that you can add functionality to above just sending speech back. And the first is when you're actually processing the information, and it's the APIs that are available to you. Amazon have a lot of different APIs available to Alexa skills, all free, just a natural part of the development environment. So when you have your flow, you get your request in. There's an awful lot of information, like I say. You get a type of request, so you know whether they've just opened your skill for the first time, so you find out if it's a new session. Perhaps they've said open the skill and ask a particular question, so that you can get straight into the detail of what the user's asking for. So you get some data back, potentially. You get an awful lot of context information though as well. You get information on the device, you get information about the user, and you get information about how to access the Amazon APIs. Quick note about user identification. When you install a skill with an Echo device, obviously the Amazon system knows who you are and which account you're running as. But as far as a skill developer is concerned, what you get back is a unique user ID. That user ID doesn't tie to your user or your account, it ties to that installation. So I may know that you are user ABC123, but if you uninstall the skill and reinstall it, I'll actually get a different user ID for you the second time round. So I can't track you through different skills. I can't monitor you in any way outside of this anonymized ID that I get back. You can link into third-party systems and ask people for their account details if you want that kind of tracking, but it's not there by default. Also, from a quick security point of view, Amazon have recently released people profiles. So it does actually listen out for your voice and gives you a different ID to potentially someone else in your house. It's a great one for me and my daughter because it means that I don't get my Spotify playlists tainted with her music selection. But yes, you get an ID back for the account, but you'd also get the ID back for the person who's speaking to you if they've set anything up differently. So when it comes to API access, you actually get a token for the account that you're working against, but you also get a token for the person as well. So if you have different settings or different information, it should be the person who's speaking to you that the information you get back from the APIs. So I just wanted to make that quite clear. In terms of enabling the APIs that we talk about, when you create a skill, you'll have a couple of options on settings, and you have to turn on functionality at the skill level to say this skill allows people to give me their name, for example, or their mobile number. But then when you install the skill, the user has the ability to accept or reject each of those permissions independently. So basically the skill has to work as a core piece of functionality, and these extra APIs are then additional options because a user can still install the skill and say, but you're not getting that piece of information. So, excuse me. So you should never expect any of the I's to be guaranteed at any point because potentially the user's not giving you that access. So it's just worth mentioning. So the first API I want to talk about is something called progressive response. Now, this doesn't extend in terms of user information, but this actually allows you to return more than one piece of speech when you are communicating with your user. So potentially they've just asked for, say, the last 6 months worth of orders, like how much have I spent with you in the last 6 months? And actually that might take your system a few seconds. When you're dealing with voice.
That was really good. Enjoyed it a lot.
When you're dealing with a skill, any kind of lag without a customer reaction is potential for them to cancel the request, do something else, and you kind of lose that interaction. So if you know that you're going to take a little bit of time to perform an operation, what progressive response allows you to do as an API is while you're processing something, you can send confirmation speech or some kind of please wait speech back to the user while your code's still running. So it's an asynchronous operation. You can actually send, sorry, I thought I'd removed all the animation from my slides. This actually allows you to send up to 5 pieces of speech. So potentially it's a please wait. And then actually if your system's a little laggy, you can potentially say, yeah, we really are going to get back to you at any real point. But then you can send the final response as your actual JSON blob with all the information you need. What this allows you to do is not only make sure that your user doesn't wonder whether or not you're doing anything, but it's also actually a really good use of passive confirmation, which is what happens when a skill will go, certainly, I'll just get that 6-month information for you. Now, actually, you're confirming what the user said, and you're responding to them, giving you a little bit more time. So by the time that speech has been spoken, it might be that actually that 6 months worth of information has been returned and your skill looks really, really fast. But from your point of view, you were just covering for the 2 or 3 seconds you needed to process that request. So progressive response, when used sparingly or when really appropriate, can become very, very useful. It also means that the user doesn't have to wait a long period of time to figure out they said something wrong. Because if you go, certainly I'll get those 6 months, and then the user may immediately go, actually, Alexa, ask for 3 months worth of information instead, and you can then process that request. So it gives the user that ability to go, yep, you definitely heard me correctly. And sometimes you do get some funny interpretations. Alexa's still really good at picking up most words, but occasionally it will get things wrong. And so that kind of passive confirmation can be really, really useful. So assuming everything's gone right and you're processing the request and you're looking at actually being able to kind of personalize the response that you're getting back and that you're giving to your users, there are a couple of APIs that let you just tweak that in terms of what the user might prefer to get back. So the first one is customer profile information. So given name, full name, mobile number, and address are the 4 different settings that you can get back. And this allows you to then use that information to personalize the request. Potentially they're asking for delivery of something, and you can actually get the address out of the API rather than having to extend the information. Or it might just be using the given name so that you give that more comfortable tone to all your speech. Kind of, certainly, Stephen, I'll get that for you straight away. It might seem like a small thing, but actually for a lot of users, that personalization, that kind of you are really talking to me feel, means that they'll stay engaged for a little bit longer. Also, having to try and get an address through on voice can potentially take a long period of time, especially if there are mistakes or strange words in the address. So it's quite, it's more convenient to try and pull it automatically and only go through a filling in process if you have to. In terms of the information, it is the information on file for the account the device is registered to. So in terms of mobile number and address, it will be whoever's account was set up to handle the device that was spoken to. Or if it's the person profile, it will be that person's information. So again, even if you do get it, it might be worth confirming by saying that's postcode ending in NG1 or whatever, to just confirm that you're definitely using the information they want. The APIs shorten the timeline, but it should always be backed up by confirmation from the user. The other API is a bit of an interesting one, is actually to do with the settings of the user in terms of things like time zone and distance. Never had to use temperature myself, but centigrade and Fahrenheit, certainly things like weather apps are very, very useful. But it just allows you to see what the user's preference is in terms of these things, so that when you're returning data, you can make sure that it is accurate or the way the user would expect. Certainly time zone is a big one. If you're dealing with bookings and that kind of thing, then obviously you've got the difference between potentially where the booking's being made for and the time zone the device is in. So it's always a good one to use if you're trying to pull that back. Or it might be that the person who's registered is in a different country to the one that their account is registered to the device. So potentially you get back that they're in the UK, but they're an American account. And so therefore you can start looking, asking them which time zone they would prefer potentially, and understand there's that difference. So again, it's little things like that that just mean that the skill becomes a little bit more personal, that the person starts getting a little bit more engaged. And although it's only a couple of seconds to ask a question, they'll feel like the skill really kind of is paying more attention and not just something they can ditch and try a different one for. So that's kind of involving the content. And I mentioned engagement, but the other thing that you can do is try and get them re-engaged quite a lot. And Alexa comes with 2 different ways of being able to do this in terms of engaging with the Alexa devices. The first one is reminders. So as the title suggests, it is literally the ability to be able to put a reminder on the device so that the Echo can tell you, oh yeah, you've got a reminder for this event, for this thing to be happening. Your order should be delivered today, that kind of thing. So we're talking about these kinds of events. With reminders, they are created while you're using the skill. So you'll ask them, say it was about a meetup, Alexa, tell me when the next .Net Liverpool is. It'd come back with the right date and time, and then you might stick at the end, would you like me to set a reminder for this? What that then allows you to do is set an absolute or relative time. So what I did with another meetup was actually they were able to go, yes, can you remind me 2 days before every event? And so you can start setting relative times up. You can do it recurring. So if it is kind of the second Tuesday or last Thursday of every month, then you can set up a recurring reminder. And once you've set up all the details, that's sent through a reminders API, and actually the user will be asked to confirm that everything your skill has to confirm that all the details are correct. So you have to, the Alexa device will say, it's this date, this time, every month, is that okay? And if you don't confirm it with the voice itself, then you won't get certified and you can't use the skill correctly. But it's a really, really good way of just getting that engagement. And certainly for things like meetups, I found it really, really useful. Some of the slides will have NuGet packages at the bottom. The main alexa.net repo has links to all of these. It's just to kind of tag the 2 together. So reminders are reactive based on the interactions for the skill, but you've also got the ability, as I mentioned earlier, to potentially push events down to an Alexa device, and these are called proactive events. So proactive events are things that are going to happen in the future, and your skill is allowing the user to ask for that to happen. So you still have to say, this is for things like if an order is changing status, so your package has been delivered, it's on its way, that kind of thing. Weather alerts, there are specific types of events that you can have these events for. So I think there's like bin collection, weather alerts, order status, games. So you can send like a score saying the score for that game has gone up, it's now 2-1. That can happen. Reservations and bookings, that kind of thing. And each one of them have a specific schema. We've strongly typed all the different types of events so that it's easy to fill in. But then the idea is that as the user is using your skill, you could potentially say, well, I'll have information about that later. Would you like me to tell you? And the user will confirm it. And as part of the confirmation work, you can get a token back that you can use in your back-end systems to send events proactively, even once that session has finished. And then what happens is when they hit the device, the ring around the device or the line on some of the screens will go yellow, and that means there's a notification. And then the user can ask that about the notification and open your skill again to potentially get more details. So it just allows you to kind of keep pulling them back in a little bit if it is something that's maybe longer than a single session. So it's not just, yeah, we took your money, the order's done, thanks very much. You can kind of keep them engaged and just make sure that they're constantly being updated with the information that happens. The statuses haven't changed a lot since they got released, so it is a pretty fixed set. This was instead of a more free text notification, so you can't create custom events. You can put information in the fields that's required, but you can't kind of customize it for something other than the specific events they've allowed for. The reason for this was for the multiple locales issue, because actually you can push the information into one of these event structures and it will correctly give that notification in any of the locales supported by the Echo devices. Excuse me. So we've gone through those APIs, and that's kind of the up until the request and code part of the cycle. So at this point, that's the way you can customize the code on with the request that you've got, kind of that first half. But the second half of the cycle, the response, is how you can actually add functionality other than speech to the information you're sending the user to make it a richer experience. So by default, you have to have speech. It's not optional, it's voice first for anything to do with Alexa skills. Not necessarily for the devices supported by Alexa, but certainly for custom skills that work on the devices themselves. But then you also have cards and directives. And these are extra ways that you can enhance the information other than through speech. Excuse me. So with cards, these are small pieces of information that get pushed onto the Alexa app. Most users will have the Alexa app on a mobile device of some kind, and it's the easiest way to set up an Echo device, or potentially they're using the Alexa website to kind of maintain their account that way. And cards work in both those environments, but they're kind of static snapshots of what you've done with your skill. So potentially, if it was, how much have I spent with you in 6 months, or what was my last role with Rollcaster, then the result of the role would go into the app on a little card, and it's just easy to flick through. So if anyone complains that's not what you rolled, you can go, no, it's right there on the card, I saw it, and that kind of thing. So it's little snapshots of information. And cards are available, they work on any device with the screen and on the mobile app. So it's kind of a guaranteed way of being able to get to the information regardless of what device is making the request. But directives really allow you to start adding and customizing it in a much more impressive way. One of the biggest, and certainly if you've seen any of the Echo ads recently, is the Alexa presentation language. In any of the posts you'll see it's called APL. But essentially this is a way of adding optional visual information to your Alexa skill. You've got the Echo shows, which are kind of 5 and 8 inch screens that allow you to work with visuals. But now as more devices with screens like TVs have Alexa built in, APL is a really interesting way of being able to engage with the user. So to go use my Rollcaster skill, this is my Echo show screen when I am asking to roll the dice. That's it. That's what I get. And it's not really the most engaging of screens. It doesn't really make you want to look at the device or help in any way. It does the job. I can say what I need, and it responds with you rolled a 6 potentially, or you rolled 3 20-sided dice and you got 14, but it doesn't engage in any way. What APL allows you to do is turn that into something like this, a much more visual, much more engaging piece of information. It's still only dice roll. It doesn't change the idea itself, but it just allows that kind of quick glance view. So even if there's noise, if the speech maybe doesn't work as well in the room as you'd hoped, then you've still got somebody who can look at the screen and go, yeah, I know exactly what's going on now. And actually this is, excuse me, this screen is actually an awfully big blob of JSON again. So everything to do with Alexa is JSON in, JSON out, and the visual language is no different. So you have text, you have the position of the text, you have a background image, you have the blurring effect on that, and everything is defined through JSON, and it can get quite big. So basically with alexa.net.apl as the NuGet package, we've strongly typed all this, and we try and do as much as we can to try and make it relatively straightforward. The designer is WYSIWYG. So this designer that you can see on screen is the Amazon visual designer. So you can build these documents, and just recently they've allowed for the functionality that you can save these documents and reference them in your skill. So there's a document link object you can use and just give a strong name. And so therefore, if you've got a guaranteed screen, you've spent a lot of time crafting, you don't have to worry about copying and pasting all this JSON around. You can reference it in your code. Or if there are things you want to build a little bit more dynamically, you can load it from the JSON, manipulate it, and then send it as part of the response. So that's using a render document directive in the APL package. And there's some basic controls: text, button, image, video. And they can be positioned, they can be set. Video has a few properties regarding the media controls. You have to be able to pause, forward, rewind, that kind of thing. But essentially there's some basic selections. And then you've got the ability to change the layout as well. So container is just an object that will contain some of the basic controls. Pager allows you to have multiple screens, and then the user can swipe on the visual and change it. So if you've got potentially like a summary view and a detailed view, then you can do that. And sequence is more of just kind of a list view. We'll just put the objects in. You can data bind inside APL. So potentially, like I say, if you've got this incredibly crafted screen, the last thing you want to do is start manipulating it too much or potentially touching it and breaking the JSON. So what you can do is reference a payload. And then as part of your skill response, you can say, well, I saved this big JSON document. Here's the payload that I want to work with it, and it'll customize the text or the speech that's referenced in the visual screen. You can also change data binding based on the shape of the screen itself. So some of you may have seen the Echo spots, which are actually a circular display. But also, if your screen is wider or bigger than a particular size, it may be that you want to put more on the screen, not do that second page after all, potentially have larger lists, that kind of thing. So it can actually potentially affect how much you're showing on screen. To show an example of the data binding, here's kind of the last 9 roles of my role history skill. As you can see, it does the job. There's a lot of black space. It's kind of cramped in the corner. And you can, and initial developers with APL did, spend a lot of time with if statements around controls. So you can say, well, actually use this if the viewport is greater than 124. If it's not, then do something else. If it's circular, do something else. And you ended up with more and more of this JSON being built and the skill becoming ever and ever more difficult to alter for what should have been quite a simplistic view. So recently is create responsive controls. So these are controls that adhere to design guidelines and will resize dependent on the display they're being pushed into. So you have headers, footers that can have buttons, hints, images, everything you need for a fully itemized list, and will allow for paging, page counters, that kind of thing. Again, all supported by our NuGet packages, but it means that we turn that awful looking black and white list into something a little richer with no more complexity than I had before in terms of object model or design. I'm just using different components. So I've been able to reuse my background image, but then I've got a header there saying what the skill is. If this was the second page, it would have a back button, and then you've got some rich results with some ordinals. And actually the ordinals 1, 2, 3, 4 down the left-hand side can actually be referenced when the user's speaking, and it will send that to you as part of the information. So these are quite involved visual controls that allow you to do quite a lot with very little infrastructure. So I mentioned before that Alexa.NET has to be kind of voice first, but you also have these pager controls where potentially you can swipe. But it's also worth mentioning that although it's a visual adaptation of what you're saying, the user can interact with those visuals through voice. They don't have to touch the screen. So potentially I've got a pager, I've got my current role, but then I've also got my role history. And so the user can say, Alexa, show my history. And then what that actually allows us to do is I can interpret that and send a command down to the visual to say, well, what they've said is the equivalent of them swiping to page 2. So can you show that instead, please? And then the command will alter the page. They can also do it the other way around, which is that the user might not want to speak, but they can potentially swipe or interact with a control on the page. And you can have user events sent back to your skill to say, well, the user just tapped number 2. So that's the same as wanting more detail about that. And then potentially that's the same as show my history is kind of the same as a swipe. So visuals can perform the same thing as the speech does, and speech can perform the same as the visuals. But it always has to be voice first. So if you enable functionality on the screen, you have to be able to get to it via speech somehow, but it just gives users that ability. Certainly in our house, lists are a big one in terms of kind of shopping lists and to-do lists that we share. And so being able to swipe an item as done, or we bought that as we go through the shopping, is a lot easier than going, well, please remove this, and then please remove that. And then, so it just gives you that kind of quicker way of getting through that result. There's a bunch of different commands that you can go through, so I've just listed those out for you. They also then recently added some slightly more advanced commands, which are to actually manipulate the items on screen. So you can set values and you can perform animations. You can also bundle these together and you can perform them on mount, which is when the visual is first displayed on the screen. And so what that allows you to do is, for example, animations where you can rotate or introduce the text and the visuals on the screen. Obviously, this was a really simple rolled example, and the video is a little jerkier than it would be on a real device, but it shows you that it can, simple animations can be done quite quickly. And actually, if you see what some people have done with APL, they've created kind of full-on adventure games where you have kind of sword swinging and enemies falling away by the wayside as you battle through a particular choose your own adventure story or that kind of thing. So you can get really quite involved with the work that's done. And with the ability to send that information down when the user says specific commands, it can feel much more interactive and much more involved and really get that engagement high. A quite new addition to my talk. This was announced a little while ago, but it's APL for audio. So essentially what this is another JSON format, but this one allows you to mess around with speech. So one of the issues originally with developing Alexa skills was that you could make them talk, or you could make the skill send down a piece of music, for example, but it was quite stilted and quite jolty. So if you wanted to create, certainly for anyone who dealt with like a story or more involved, if you wanted kind of that game show feel of having background music while a timer was ticking or something like that, you had to essentially craft all these yourself and then put all the audio together, mix it down, and then upload an MP3 and use that as the speech. And so it did get quite involved. What APL for audio allows you to do is, with a bit of JSON, it lets you combine these together, and actually the Alexa ecosystem will generate an audio effect that will then get pushed down to the device. So the controls on the left are what you can create this audio out of. So you can create speech, audio as in MP3 files, or you can insert silence if you needed a guaranteed gap between particular other elements. All of these can then be cut or reduced in volume to allow that kind of background noise effect. And that's all done by adding filters to individual elements. And then with these elements, you can perform work with them through the controls on the right, which allow you to mix them up. So you've got a mixer, which plays all the elements that you give it at once. You have a sequence, which plays them in order, and then a selector, which allows you to do the same kind of thing as you did with APL with data binding by saying, well, actually, give me all the possible options you might want to play at this point, and I will pick the first one that matches based on the criteria that you give me. So the first one might be, well, only play this one if the user's won, play the second one if the user's lost, and actually it's part of the JSON result that determines that. And so what you end up with is a blob of JSON like this. Now, hopefully this recording works. I cut that short because that's quite a long demo, but it shows.
We can't hear that. We can't hear that audio there, Stephen. Sorry.
Oh no.
Strange.
No, that's unfortunate. Sorry. In which case, it's what you would have heard was some game show waiting music, which is the audio down here, and then the first half of this sequencer here, which was a bunch of different individual pieces of audio. So yeah, sorry that you can't hear that. That's a shame. But it allows you to really, like I say, it allows you to mix that audio up and start creating more interactive experiences. Certainly for Rollcaster, it just meant that I could kind of put some gaming sounds in of like actually rolling the dice. Previously, it was quite stilted. You got the full effect and then it had to stop for a second and then you got the result and it just sounded really awful. It really wasn't worth it. And I actually ended up taking the sound effects out. Whereas now, because it's such a smooth experience when you've put the JSON in, you can start adding these little effects and it feels a little bit more natural. I've also got a game skill that allows you to create battles. And so I've got really, really quiet kind of battleground sounds at while the response is going on. And then Alexa explains to you what moves you've made. And then if you've like scored a hit, then you get kind of a cry at the end. But it's all one, as far as the user's concerned, it's all one experience. So you don't feel that kind of jilted combination of playing one thing and then the other. There is, I'm not going to go into it very much, but I did want to mention that they have recently made for general availability Web API for games. So if a voice experience is really your thing, but you know that you want to pitch at users who have devices with screens and you really want to make that next level of interaction where you want a full-on game that just happens to have voice, then I'd thoroughly recommend looking at Web API for games. And what this allows you to do is essentially generate, when you open your skill, you can point it at an HTML page and it will run with OpenGL and the full advantage that you have of browser rendering. But when the device picks up on voice, it actually uses that to send a request back to your skill, and then you can send something back to the game to interact. And equally, if then something happens on screen, an event can be sent via JavaScript back to the Alexa event, and they've essentially got a JavaScript API that interacts with the Alexa ecosystem. So you can have voice-enabled full rendering games, and that's what some of the kind of the big players are starting to look at now. But that's just become general availability. Most of the time you are in HTML and JavaScript, but I wanted to mention it because the APIs are supported by Alexa.net as well. So you've got your game, you've got your skill, you're getting that information back, but one of the things that people often want to do with these things is actually make money. So you can do in-skill purchasing. In-skill purchasing allows you to work with 3 different types of products. So you have an entitlement, which is essentially a one-off product purchase. So you buy it and then you've got it. And the API, when a user interacts with you, you can actually use the API to confirm that the user has definitely got that thing before you allow them to use part of your skill. The core functionality of the skill can't be behind a paywall. It always has to be kind of optional extras. Otherwise, it won't get certified. But certainly if you wanted like that extra level or that different story, if you want, I could potentially say as a one-off cost, you could use dice that were larger than 20 sides if you paid like $1.99, that kind of thing. Subscription speaks for itself. It is a regular monthly subscription. And you can put a free trial on it, and Amazon deal with all that kind of handling. And then you use the API to ask if there is an active subscription at the moment. And then a consumable is something where you can buy a number of items and it goes down over time. So for example, lives in a game, hints to complete a puzzle or to answer a riddle, that kind of thing. So consumables will go down and can be repeatedly bought time and time again. It's worth mentioning that with the products, you can't mention the price of the product when you speak about it in the skill. You can say, I have this thing, would you like it? The reason that you can't put the price in it is that, as with most other stores, Amazon do a 70-30 split in the developer's favor, but certainly for Prime members or on Prime Day or on special offers, Amazon will manipulate the price of any of your products, and they will manipulate that out of their 30%. So potentially the price you get doesn't accurately represent the price that the user paid to get it. So you're not allowed to mention the price in your skill. It will come up on screen as this is the price that is available. Amazon deal with all the credit card takings. It all goes through the Amazon account. All the subscriptions are handled through it that way as well. You don't do anything with that. What you do is you say, would you like this? And the user says yes. Then you can send a request down to say, well, I have product ID 1234. I would like to make this user buy it, please. Potentially you can upsell from an existing product, so it will replace one with another. Or you can say, actually, the user said that they're not that bothered anymore. So you can send that down. They go through all the purchasing screens. So it comes up with this, and this is why you can't mention the price, because I set it up for 99p to get the history of my roles, but potentially that could have been 89 or 91, whatever Amazon decide. That screen comes up, or that will come up on the device if it's not on a screen device. And then what you get back is a response that simply says they bought it, it was already owned, it was purchased if it was an entitlement, or potentially they cancelled. So you get a status back, and Amazon deal with everything else in the middle. So essentially it terminates your session, so you're not involved at all with anything to do with credit cards or with confirmation or account details. And that's quite important from a security point of view, but also from the user understanding that they're still dealing with Amazon. Gadgets has changed quite a lot. Normally, this is quite a large section, and that's because Amazon had, some of you may have seen Alexa buttons, which were kind of built for gameplay. Recently, they have removed that access and made it part of a general gadget framework. So gadgets work via a system called custom Alexa interfaces. Essentially, any Bluetooth device can potentially be an Alexa gadget. If you're into your IoT, there is a very detailed document on the protocol that you have to adhere to. Pairs over Bluetooth, uses protobufs to communicate with your device. And that's all dealt with by the Alexa device and a gadget. You can buy Singing Santa, you can buy Singing Fish. There's a couple of like Amazon devices. There's an Alexa clock, which I haven't used personally, but I have seen, which connects this way. And essentially, these are still Alexa-enabled devices. Something happens on the device, you pair them up and say, well, actually, I want this gadget to work with this Echo. And then once you've got that connection, you're able to send commands down to the gadget. So potentially, I've imagined I've come up with a gadget-enabled IoT rollcaster that rolls real dice, and I just record the results by figuring out where the dice were on the floor. I can send it down to say roll, and I can send that down just in the usual JSON blob. All the Bluetooth stuff's handled by Alexa, and then, or I could potentially say, tell me when something's happened. And then the gadget can come back and the gadget will send you your skill a request saying, yep, here's an events received request and here's all the information. And that schema is dependent on the device. So there will be an agreed contract that you'd be expecting and you can pick that up. So potentially my rollcaster's got, you know, an array of dice values that I would store. But gadgets is quite a big thing if you're into IoT, and you can get some fun stuff. I think the big one that a lot of people use is the Lego Mindstorm robot, because that hooks in really quickly. And then you can start sending commands down to the robot to move around, turn, make a noise, that kind of thing. So that's quite fun. There's some other smaller bits and pieces I wanted to just go through. They're the kind of the big ones. The APIs, the purchasing, APL are the bigs, but there are some other areas that it's worth knowing about. Certainly in terms of personalization, you can send directives down that allow you to personalize your skill. And the way they do that is through something called dynamic entities, which is essentially a way of saying the skill out of the box will accept values. For example, for rolling, I might say, well, actually, this skill will always accept the word roll and then the number of dice and the number of sides. So roll 3 20-sided dice. But with dynamic entities, I can actually send new values down when I know who the user is and say, well, you'll accept that, but actually, if they say any of these other things, I also want to know that as well. And then potentially, if, I don't know, if you're a D&D player, you could use the name of the spell rather than the number of dice that you need to roll for it. and maybe your skill figures that out for you and sends the right result back. And it allows you to customize it based on the information. Dynamic entities can also then be used with things like in-skill purchasing. So you can say, well, actually, you have to roll all the dice and figure out who needs what for what spell, or you can have a $2.99 a month subscription and my skill will do all that work for you. Thank you very much. So it's a nice way of kind of doing a bit of an add-on package that way. So that's most of the directives. That's kind of in terms of actually adding to the skill itself in .NET and with the work that you can do with the request response model. But there are just a few quick bits and pieces I want to mention just because they're really, really useful. Alexa Quick Links is something that's been recently announced. Basically what this allows you to do is you can have a mobile app and you can actually link to an Alexa skill from within an app itself. There is quite a lot to this, so you can do account linking if potentially you're dealing with people who have had to log into your app rather than them then logging into the skills separately. You can log in from the app itself. You can perform tasks or you can try particular skills in the example on screen where actually it gives you a list of the registered devices for this user and go, well, certainly, would you like to try the skill on that device? So it's a nice way about a push a skill version along, but also you can perform any of the tasks that you can perform in the skill. You can potentially get a specific URL and trigger them from within the application. More and more, Amazon seem to be trying to create functionality that allows you to type voice and mobile together. Certainly for Android devices, you can have Alexa as your built-in smart assistant instead of Google. So that's quite a useful add-on. Alexa.net.management, one of the NuGet packages we maintain. This is essentially an entirely API-driven way of handling Alexa skills. So add new versions, create new slots, alter intents, add a new locale, get statistics back, run tests if you want to start putting that into kind of an automated pipeline for deployment. You can simulate the speech, you can run full sessions and send the text through about what the user should have said, so you can automate all that, all done through Alexa.net.management. I built it so that I could create a Windows 10 skill manager. It was an interesting experiment to see if I could, and then actually it was easier to be able to double click an app than having to log into Amazon every time. So I have this now. And just recently, they've also added full catalog management for slots. So potentially if you have a store or something like that, and you want a user to be able to say, hey, give me details on, and then kind of insert product name here. Potentially that's an awful lot of typing for somebody to maintain that. You can actually point Alexa at an API or at a file and say all the product names are in there, and you can then trigger that, upload a new file or point it at the API and ask the skill to relearn all the values that you've put in, so you can keep your product lists up to date. So anything where there's a lot of change and you wouldn't want to have to try and maintain the list manually, all done through the management API. Really, really powerful stuff. For anyone into automation, I'd really recommend it. I spend a lot of time maintaining this one because they keep adding to it all the time. And then the last one is just kind of a nice one for code maintenance and keeping your .NET code kind of clean. It's called request handlers. It's a pattern that Amazon themselves have put into their Node and Java libraries, but essentially it allows you to create classes that are separated based on these two methods. So you have a can handle method and then a handle method. Basically, when a request comes in, what this system will do is it will look through each of your request handlers and run the can handle method, and then it will invoke the handle method of the first one that returns true. And what this allows you to do is just isolate your logic. Some of this stuff can get quite big and quite complicated. Certainly if you've got involved dialogue where there's a lot of backwards and forwards, sometimes you really want to just kind of make sure that that code is kept clean. And so request handlers allows you to do that. For my rolecaster skill, This is just the kind of a list of the different things that I did. So you've got the launch, you've got rolling, being able to roll again, but then certainly when it comes down to purchasing, you've then got, well, actually, did they ask for a specific product or any product? And then all the different states of what happens, whether they purchased it, whether they decided not to, whether there was an error. So all of a sudden it can get quite big quite quickly. And each one of these is now its own class, all handled independently. Certainly if you're running with a Lambda or maybe your own API, what this allows you to do is have a little touch point inside your existing code to say, now just run the request handler pipeline. And then potentially have a whole separate package, separate library or something that has all the classes in it that maintain Alexa, so it can be maintained separately. So request handlers is an available package that just really allows that separation of concern in terms of maintaining all your code. So that's everything I've got to say, and that's been quite a lot. Thank you for listening to me. In terms of resources, I would absolutely recommend the Alexa blogs. They have split it down quite recently, so they subcategorize. For those of you who are more into the science, really, they've got quite a lot of technical people blogging on how they do the natural speech, how they stop Alexa understanding when adverts come on that use the word Alexa. They actually tweak the audio in the ads so that Alexa knows not to listen to it. It's really interesting details, but also all their new features are detailed in there as well. The Alexa team have a design guide, helps with every aspect of the developing skills. So that can be for everything from in-app purchasing to how to get certified, to API, good design for screens. It's everything possible. And they add to that pretty frequently as well. That's a regular one for me. And then if you have any trouble, anyone on the Alexa team worth their salt follows the Alexa Devs account. So that's where all the announcements come through, but also a quick and easy way to kind of reach out and go, help, I've got this thing. Does anyone know where that problem is? So thoroughly recommend following Alexa Devs if you're starting to get interested in voice. And that is me. Thank you very much.
Thank you, Stephen. That was absolutely fantastic. I wrote loads of questions down that I was going to ask you, and you kind of ticked all the boxes as you were getting along. But just from me, I just wanted to emphasize how amazing this library is, because I started off not knowing about Alexa.net, and when I was doing my Alexa skill, I kind of was like, oh, okay. So looking at the documentation, I was like, I have to return this JSON. And then when I found the library, it just made everything from authenticating, because you've got libraries for authenticating there, and you said about the event handlers that you've got. So it took weeks of work in basically a couple of days. It was just absolutely fantastic. So my question for you is, how many Alexas do you have, Stephen?
In the room, in the house, okay, I have 1, 2, 3, 4, 5, 6. There are 6 in the house. They're active all the time. And then I have 2 or 3 that are just for testing different kind of screen sizes. Plus the downstairs television is Alexa enabled. So I don't know if that counts or not, but yeah, we have a lot. Almost every house has at least one device in it now. We're pretty used to just shouting what we need, and something in the house will pick it up. My daughter has her own, which is bound to her account. And we've just been able to put some kids restrictions on there, but yeah, she's a teenager now, so she quite enjoys being able to just stick her Spotify playlists on and that kind of thing. But yeah, we have a lot. I've been very lucky with my family not getting more cross with occasionally some random voice just calling out going, I'm sorry, I didn't understand what you were saying. Yeah.
And one more question. Did I hear it right in the presentation that you said it can identify the user that's not signed in by voice or?
Yeah, if you go to the Alexa app, there should now be an option that says something like recognize my voice or learn my voice. And that's essentially person profiles. So my wife has her own Amazon account, but she has used it against our Alexa devices. So although the device is registered to me, when she says something, it's her credentials and her account linking that kicks in. So certainly for a company like mine, Experian, one of the things that we had to wait for to even begin to look at voice was always going to be that actually what happens if someone just said, "What's my credit score?" Because anyone could shout that, and that would be a huge security breach. So for anyone who was ever worried about the wrong details being said out loud, person profiles are something that you can start putting in. And actually, for that kind of thing, it's great because the skill still works, but because you don't get a person ID back, you can go, "I'm sorry, but because this is personal information, we would prefer it if you enabled this option in the Alexa app," and kind of help the user through that a little bit. But yeah, there is supposedly, I'm sure I saw, it might have been in their last hardware event, that they're looking at being able to build in functionality for like a 4-digit code as well, and that they'd handle all that so that you just get it has been authenticated as a protected skill, that kind of thing. But that's not come out yet, so that may have been rumor mill, but yeah.
That's really good to know. I'm always a bit iffy about security with the Alexa, but you've got to trust it at some point, don't you? Is there any more questions from anybody before we wrap things up? Got one from David in the chat. So with the API with WebGL, is that only for the Alexa devices, or can it work with the web-based games through a website?
That's an interesting one. If you had an existing game that worked in a browser, then the issue is going to be that for although your devices would work, however, for certification, Alexa skills have to be voice first. So I'd imagine you would get a problem at the point of certification. So potentially, though, you could do it as an optional extra. So you could have a WebGL game and then look to see if the Alexa functionality was available in the JavaScript API. And if the object wasn't available, then you just work it in kind of a non-voice mode. But yeah, the biggest issue you get with some of the new functionality is that users forget that it's still voice first for these devices. But and if it's not an Echo device, obviously your mileage may vary with all these optional extras. And so it's always recommending checking to see what functionality is available coming from the request, because potentially you might have the screen, but the web API may, the browser functionality required for the web API for games may not be supported on that particular device. But you get a bunch of interfaces from the device sent as part of the request. But yeah, although you could, I think you'd have an issue with certification.
Great, thank you. So we've got a thanks from David there. And the last one as well is just based on the Alexa.net and just maintaining that. Have you found that integrating with their APIs and doing this repo is a lot of breaking changes, or has it been quite an easy road to where you are now with the library?
The team are fantastic. Their documentation is 95% perfect, I would say. One of the things that you do notice when you're working with so many different APIs is that the documentation is never perfect. So there's been a couple of versions, but breaking changes, they're normally pretty good on. They version everything inside the URL. So although it's normally mostly the same URL, you'll end up with a /v1/v2 kind of thing. I think having breaking changes in the NuGet packages is more common, because we decide when we feel comfortable to move to a V2 potentially. And then you're always going to have some users who are then, why the hell are you not supporting the V1 features still? And it's like, well, we have to make a decision to move on at some point. So, but we always make that really clear. We use semantic versioning on all our APIs. So it's a major version change in the NuGet package when the API changes as well, so that the developers, we don't kind of cause any problems for developers who didn't realize they were going to be introducing potentially breaking changes. But no, the teams for Amazon are really, really good. And they don't release anything without a tremendous amount of documentation. So I think the biggest issue I had was with APL. One of their later versions just added so much functionality. I ended up having to rewrite some of the core .NET code that I had that was trying to figure out what the JSON was supposed to be. And so I think they released it, and it took me about 2 weeks before I could release a NuGet package update for that version. So, but no, normally they're pretty good. And I work on these libraries so much now that in terms of support, we're normally pretty quick in supporting everything. If they make a new announcement for an API or a change, we try and get it in within a couple of days. So we try not to be too far behind the official SDKs.
That's brilliant. Thank you for your support on the library and maintaining it for us. And thank you for giving up your evening as well to open our eyes up with a lot of new features that we didn't know about.
As you might better tell, I love talking about this stuff. So thank you very much.
Thank you.